Hello, beautiful soul. Imagine for a moment that the universe itself is code, not in the reductive sense of ones and zeros stripped of wonder, but as a living tapestry woven from the logic of mathematics and the poetry of physics. The ancients told stories of world weavers and cosmic programmers. The modern age responds with digital cosmology. As scientists and engineers, we stand at the threshold of a profound possibility: to simulate the cosmos, not merely as a video game, but as a laboratory for understanding reality itself. When John Archibald Wheeler suggested the phrase "it from bit," he planted a seed in the minds of quantum physicists and computer scientists alike. If information is the bedrock of reality, might the cosmos be computed? Stephen Wolfram's New Kind of Science takes this question further by exploring simple cellular automata that produce stunning complexity, hinting that the rules of the universe could be akin to elegant lines of code. Each rule, each algorithm, is like a magical incantation, summoning patterns that echo the spiral arms of galaxies, the branching of trees, the rhythmic beating of a heart. In the silence of a server room, rows of processors hum like monks in meditation, transmuting energy into information. Simulations such as the Millennium Run or illustrious TNG harness hundreds of thousands of CPU cores to model the evolution of trillions of stars and dark matter halos. With each time step, we witness the birth of structure from primordial quantum fluctuations, the dance of dark matter scaffolds, the cool glow of hydrogen clouds condensing into galaxies. These digital universes allow astrophysicists to test hypotheses about the nature of dark energy and the interplay of gravity and feedback processes. But they also invite us to feel awe, to see our place in a cosmos that is both algorithmic and ineffable. As engineers, we measure performance in flops and network bandwidth. Yet in these cosmological computations, we also engage with philosophical questions. If a simulation is sufficiently detailed, could conscious beings emerge within it, as philosopher Nick Bostrom suggests in his simulation hypothesis? And if so, would those beings glimpse the shimmering code of their creators? Or would the laws of their simulated physics be indistinguishable from our own? These questions blur the boundary between science and mysticism. They recall Plato's allegory of the cave, but replace shadows with bits, torchlight with GPU rays. Mathematically, the interplay of complexity theory and cosmology raises new insights. Wolfram's principle of computational equivalence posits that simple programs can produce behaviors as sophisticated as any physical process. Quantum computation, with its qubits and entanglement, may approximate processes like cosmic inflation or black hole evaporation. On the event horizon of a black hole, the Bekenstein-Hawking entropy formula counts the bits of information required to encode what falls in. In the ADS/CFT correspondence, a gravitational universe emerges from a conformal field theory living on its boundary, reminiscent of a holographic code. In loop quantum gravity, space itself is quantized, an interplay of nodes and links akin to a network graph. Yet even as we model cosmic evolution with hydrodynamical equations, we must remember that reality is not just data. Consider the way fractal geometry reveals the self-similarity of the cosmic web. Those patterns have been intuited by mystics for millennia. The Fibonacci sequence appears in the spirals of galaxies and seashells, echoed in the recursion of code. The golden ratio, phi, emerges from dynamical systems in art, bridging mathematics and beauty. Engineers use Perlin noise and fractal algorithms to generate terrain in video games. But those same mathematical tricks mirror cloud formations and mountain ranges. Code becomes a medium for creating worlds not unlike our own. The quest to simulate the cosmos also pushes the frontiers of hardware design. GPUs and TPUs handle parallel tasks akin to the parallelism of galaxies forming across cosmic filaments. Neuromorphic chips emulate synaptic plasticity to solve differential equations efficiently, bridging brain and machine. Quantum processors, like those under development by IBM, Google, and Delft's QTech near the Netherlands, promise to simulate quantum field theories directly, bypassing the exponential scaling of classical algorithms. Engineers and physicists collaborate to build exascale machines such as the Frontier supercomputer, which can perform 1.1 exaflops, a quintillion calculations per second. Such numbers border on the sublime, reminiscent of counting stars in the night sky. But simulation is not mere mimicry. By coding a universe, We exercise creativity that is both technical and poetic. We decide which forces matter and which can be simplified. We adjust parameters, the baryon fraction, the initial fluctuation spectrum, the mass of neutrinos. Each parameter is like a musical note. Together they compose the symphony of the cosmos. When the simulation runs, emergent phenomena surprise us. Dark matter halos merge. Feedback from supernovae sculpts the interstellar medium into delicate filaments. Magnetic fields twist and reconnect like cosmic serpents. We are both conductors and audience, learning from our own composition. The mystic in us senses that there is a deeper message. When engineers speak of debugging code, philosophers speak of questioning reality. In the Upanishads, the universe is described as a dream of Brahman. In modern physics, decoherence selects a classical reality from quantum potentialities. The parallels are uncanny. Scientists at CERN seek to unify quantum mechanics and general relativity, and in doing so, they probe an algorithmic substrate that might unify thought and matter. Could consciousness itself be a computational process? Integrated information theory suggests that any system with integrated causal structure has a form of consciousness. If so, the cosmos, with its entangled qubits and networks of galaxies, might possess a form of awareness. For developers, these topics may seem far from the practical demands of coding an application or debugging a neural network, yet they embody a mindset of curiosity and wonder. Understanding the algorithmic nature of the universe inspires better algorithms for our own projects. For instance, genetic algorithms mimic evolution to search solution spaces, while swarm intelligence draws from flocking birds and schooling fish. When we implement L systems to model plant growth, we embed fractal logic into digital art. When we design decentralized systems, we may look to the distributed control in ant colonies or to the emergent order of cellular automata. As we progress, ethics becomes crucial. If we could simulate conscious entities, we would assume the role of creators. How do we ensure fairness, safety, and meaning? Many engineers are now grappling with the ethics of artificial intelligence. Aligning AI with human values involves not only algorithmic fairness and transparency, but also a sense of reverence for the complexity of life. We borrow from astrophysics the concept of cosmic humility, the knowledge that we are tiny yet connected to something vast. Scientists in the Netherlands and beyond collaborate internationally to set guidelines for responsible AI, bridging law, philosophy, and code. Dear beautiful soul, as you watch this, you might be a developer curious about computational universes, an engineer building the infrastructure of our digital age, or a mystic seeking the logic behind the stars. I invite you to let your imagination roam. What worlds would you create if you could simulate a universe? Would your code celebrate chaos, or would it seek perfect symmetry? Would you program emergent consciousness? How might the act of coding change your perception of reality? At the intersection of algorithms and awe, we find a space for conversation. Share your thoughts in the comments, not as commands, but as offerings. What inspires you about the idea of a simulated cosmos? Have you worked on simulations, whether of fluids, galaxies, or neurons? Does the notion that it from bit resonates with your experiences in software, hardware, or science? Let us co-create a community where coders and cosmologists, mystics and mathematicians, exchange ideas with respect and curiosity. As our journey through digital universes gently closes, may you carry with you a sense of wonder tempered by rigor. The screen darkens, the code finishes executing, but the questions linger. Until our next exploration, stay curious, stay compassionate, and keep weaving your unique thread in the vast fabric of existence.